Objective, function rules, tables, and graphs. Couple definitions. Definition number one, a function table is a table organizing the input, the rule, and the output of a function. Definition number two, the independent variable. These are the input values or your x values or your domain. Make sure you know that independent variable goes with the domain. Definition number three, the dependent variable are the output values or the y values or the range. Make sure you know range and dependent variable mean the same thing. Vic number one, there are three views of a function. One is the rule. You might see y equals 1/2 x plus 3, or f of x equals 2x squared, or g of x equals 3 plus 5x. These are rules. Or it might be in the form of a table. So you have an x, your rule, and your y. Your input, the rule, and the y. And you might also have the third view is just the graph. So if you take y equals 1/2 x plus 3 and type it into your TI-83 or 84 graphing calculator that you should have now, you should see the graph of this line, this function. Completing a function table. Model each rule with a table. So example number one, our rule is f of x equals -3x. So we have our input, that's x, and our output, f of x. We input x, we get out f of x. So if x is -2, we take x out and plug in -2 everywhere x was. So f of -2 equals -3 times -2. A negative times a negative is a positive. So we get out 6. -1, plug it in where x was. Take x out, put in -1. -3 times -1 is 3. 0, plug in 0 where x was. 0 times -3 is 0. 1 times -3 is -3, and 2 times -3 is -6. Similarly, if our function rule is f of x equals 1/4 x, these are our x values, -4, -1, 0, 1, and 4. Now, I chose these to make these numbers come out nice. Most of the time, you're going to use -2, -1, 0, 1, and 2 for your x values if the problem does not give those to you. So if you can choose your x values, you want to choose small numbers, some positive, some zero, some negative. So that way you can see what the shape of the graph is. Now, not always will you choose these numbers, but most of the time if you have a choice, you're going to want to choose some on either side of 0 so you can see the full shape. So here I chose -4. -4 times 1/4, take x out, put -4 in parentheses. You must use parentheses. I cannot stress how important it is to use parentheses in these problems when you're substituting for x, because if you don't and you're relying on your calculator, you're going to get the wrong answer in some cases. So 1/4 times -4 is -1. If x is -1, our output is -1/4. 1/4 times -1 is -1/4. Take x out, plug in 0. If x equals 0, 1/4 times 0 is 0. If x equals 1, plug in 1. 1/4 times 1 is 1/4. If x equals 4, plug in 4. 1/4 times 4 is 1. So we could write these. This is a table. You could take the table and write ordered pairs. -4, -1. -1, -1/4. 0, 0, 1, 1/4, and 4, 1. This could be a set of ordered pairs. A table is another way to display a function, also a relation. All right, example 3, sorry. If our rule is y equals 8 minus x, and x is -2, then we're going to replace x with -2. So y equals 8 minus, use parentheses, 8 minus a -2 is 10. If x equals -1, take x out, put in parentheses, -1, 8 minus -1 is 9. If x equals 0, 8 minus 0 is 8. If x equals 1, 8 minus 1, in parentheses, is 7. And if x equals 2, 8 minus 2 is 6. So this would be a function table to model this rule. Graphing functions. Example number 4. Y equals the absolute value, remember these bars mean absolute value, of x plus 1. Purple. Here's a table. So in this column we have our x values. Here we have our function rule and y. Here are our outputs. Input, output. This is what has happened in between. So we take our x value, -3, and we plug it in where x was. So I've substituted -3 and plus 1 carries down. Absolute value of -3 is +3. 3 plus 1 is 4. Absolute value of -1. Take x out, plug in -1. Absolute value of -1 is 1. 1 plus 1, 2. Absolute value of 0, 0 plus 1 is 1. Absolute value of 1 is 1 plus 1 is 2. Absolute value of 3 is 3 plus 1 is 4. Now I can take my table, my x's and my y's, and I can write this as a set of ordered pairs. -3, when x is -3, y is 4. So that's one ordered pair. -3 for x, y is 4. -1, 2 as an ordered pair. 0, 1 as an ordered pair, 1, 2 as an ordered pair, and 3, 4 as another ordered pair. This is our function. It is a set of ordered pairs. It's a special kind of relation. None of the x values are repeated. Now, the y's can be repeated. Remember that. 4 shows up twice as a y value, that's fine. 2 shows up twice as a y value, that's okay. X's cannot be repeated if it is a function. Now this is an absolute value graph, and if you go ahead and look at this, it is a V-shaped graph. Make sure you know that absolute value graphs are V-shaped. V-shaped graphs. Now where did these points come from? Well, these are our ordered pairs that we've written down from our table, -3, 4. That means you start at 0, 0, you go left 3, 1, 2, 3, so that's at -3, and we go up 4, 1, 2, 3, 4, and here's a point. This point is on the graph of the function. -1, 2, go left 1 and up 2. 0, 1, go left and right, none, and then up 1. Remember, we always move left or right first, and then up or down. Our first number tells us left or right, so +1 means to the right 1, and 2 means up 2. If we have 3, we go to the right 3, and then up 4, and there's our point. So you connect these points and make sure you draw arrows on the end to say that the graph continues on in both directions. Let's do another example. Example number 5, f of x equals x squared plus 1. So again, I've drawn my table. Here's my function rule. I've chosen -2, -1, 0, 1, and 2 as my x values. Substitute where x is. Make sure you use parentheses, especially if you have an exponent, because that's going to change the value if you forget your parentheses. So -2 squared, that means -2 times -2, which is +4, plus 1 is 5. -1 squared, so I'm plugging in right here where x was. The squared stays, the plus 1 stays. The only thing that changes is where x is. So -1 squared plus 1 is 2. 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 more is 2. 2 squared is 4, plus 1 is 5. Each time I've taken my x value and I've substituted it in both places where x was in the function rule. And I've gotten my outputs. Now, f of x, right here, f of x and f of x. This says what came out. Okay, when I did the rule, what came out? Inputs, outputs. These are like your y values, your outputs. So we can take them and write them as ordered pairs. -2, 5. -1, 2. 0, 1. 1, 2. And 2, 5. Now I can take these same 5 ordered pairs and plot them on my graph. So -2 means go left of the origin 2, and then +5 means go up 5. There's that point. -1, 2, go left 1 and up 2. There's the point. Over 0, up 1. So don't go left or right any, but go up 1, and there's another point. 1, 2 means go to the right 1 and up 2. And 2, 5, go right 2, up 5. Now this graph is symmetrical, just like the absolute value graph was, but this has a U shape to it. Okay? The secret word is parabola. And so this is a quadratic function, and we'll discuss that more in a later unit. But the graphs of quadratics are always U-shaped. And you spell parabola P-A-R-A-B-O-L-A. All right, an application problem. So Juan charges $3.50 per hour for babysitting. Write a rule to show the amount of money, and we're going to call it M, earned as a function of the number of hours, H, so number of hours is H, spent working. So here's our function rule. The money he made is $3.50 per hour. So per means multiply. So 3.5 H. I've drawn the function table. H. So I started with 0 here because he can't make any money if he doesn't work at all. So we can't have a negative number of hours that he worked. It's just not applicable for this problem. So 0 hours, we say 0 hours times 3.5 is $0. If he works 1 hour, 1 hour times 3.5 is $3.50. Remember, M is money. 2 hours at $3.50 an hour makes $7. 3 hours, 3.5 times 3 is $10.50. And 4 hours, 3.5 times 4 is $14. So I've taken 0, 0, here's that point, each value, and I've plotted it on the graph. Remember, this is how much money he's earned, and this is the number of hours he spent working. So if he works no hours, he makes no money. If he works 1 hour, he makes $3.50. So it's right about 3. If he works 2 hours, he makes $7, so a little bit above 6. If he works 3 hours, he makes $10.50, so it's bigger than 9. If he works 4 hours, he makes $14, so 4 hours, $14 is a little bit close to 15. All right, so I've plotted my points and I've drawn a line through them, so this can be used to predict how much money he would make if he worked 10 hours. So using the function rule, we can say, well, 10 hours, he would make $35 because M equals 3.5 times 10 hours, and that gives you 35. So M equals 35. And in the context of this problem, 10 would be hours, and 35 would be the amount earned. Make sure that you can interpret what the function rule means in the context of each problem. And remember, this can be used to predict.